In part B, we have to find the range of f. Now, from the original function, which we converted to the form 2 into x minus 4 whole squared minus 9, we know that the turning points are at 4. The coordinates of the turning points are 4 and minus 9. So making the turning points on the x and y axis. So let's say this point is 4 and this point is minus 9. So the quadratic graph would be made like this with the turning points at 4 and 9. Now, once we have the turning points at 4 and 9, we know that the least value of the graph is minus 9. However, if you look at the domain of f of x, that was x is less than 3. So x equals to 3 will lie up here. So first, we'll have to find the value of x at the value of function f of x at x equals to 3. So substituting x equals to 3 into the function, we'll get 2 into 3 minus 4 whole squared minus 9. So 3 minus 4 whole squared, that will become a 1. So 2 minus 9 will be equals to minus 7. Now, as x is less than 3, and we can see that the graph will always be going upwards for x less than 3. And this value at x equals to 3 is minus 7. So we can say that f of x will be greater than minus 7. In part C, we have to find an expression for f inverse. Now, to find the inverse function for a quadratic function, we must always convert it to the complete square form. As we already have the complete square form, which is 2 into x minus 4 whole squared minus 9, we can find the inverse function by first writing y in place of f of x. So this will become y equals to 2 into x minus 4 whole squared minus 9. Now exchanging the values of x and y, we'll get x equals to 2 into y minus 4 whole squared minus 9. Taking 9 on the left hand side, we'll get x plus 9 is equals to 2 into y minus 4 whole squared. Now dividing it by 2, so x plus 9 will divide by 2, and that will be equals to y minus 4 whole squared. Taking the square root on both the sides, so this will become y minus 4 will be equals to the square root of x plus 9 upon 2. And finally, we'll take 4 on the right hand side. So this will become square root of x plus 9 upon 2. And the 4 will come here and this will become a plus 4. But as with the square root sign, we have to add a plus and a minus sign. So this will become 4 plus minus square root of x plus 9 upon 2. Now, for a function for f inverse to be possible, the range of f of x was greater than minus 7. Now, for the function to be great, the range of the function is greater than minus 7, which means that, or we can say that as the domain of the function was less than 3, so the range of f inverse as the f inverse function is 4 plus minus square root of x plus 9 upon 2. This whole value must always be less than 3. Now, if we take a plus value, the range of f of x will be greater than 4. But as the domain of a, so what we need to understand is that the domain of f of x is equals to the range of f inverse of x. So the domain of f of x was x is greater than 3, which means the range of f inverse of x will also be greater than 3. It was less than 3, so this will be less than 3. Now for the range of f inverse to be less than 3, there must be a negative sign up here. So if it was a positive, it will be 4 or more. So we'll write f inverse of x will only be 4 minus the square root of x plus 9 upon 2. So for this value, this will always be less than 3. In part D, the function g is defined by 2x plus 4 for x less than minus 1. We have to find and simplify an expression for fg of x. Now, f of x, we already know it is 2 into x minus 4 whole squared minus 9. To find fg of x, so in place of x, we'll write the function g of x. As g is 2x plus 4, so we can write 2x plus 4 in place of x minus 4 whole squared minus 9. So this will be equals to 2 into 2x. 4 minus 4 will become 0. So this will be 2 into 2x whole squared minus 9. 2x whole squared will become a 4x squared. So the final answer for fg of x will be equals to 8x squared minus 9.